Okay, in section 10.3, we're going to talk about chords, but we're also going to talk about arcs and central angles. Okay, so this is more than just chords. It's about arcs and it's about central angles. Okay, and we've defined what they are, but we're going to look a little bit more closely at those. And so a chord has endpoints on the circle. So this is a chord, VT. It's a segment. Okay, segment has endpoints V and it has an endpoint at T, and those two endpoints have to be on the circle. Now we talked earlier about how a diameter is actually a chord because its two endpoints are on the circle, but a diameter has to go through the center and a chord does not. Okay, so if I've got a chord up here as well, this is segment YZ, and that is a chord. You can see that the measure of the central angle here is 55 degrees. I would name that as angle YXZ. Okay, that's 55 degrees. Now, using some of the things that we've learned all year long, I know that this angle and the angle over here, this would be angle VXT. Okay, that would have to be equal to 55 as well. Okay, not only are they both central angles, but they're vertical angles to each other. So that concept still applies. So both of those would have to be 55 degrees. And we already know that the arc, okay, this is the central angle here, but the arc is out here on the outside part of the circle. We'd say that's 55 degrees as well. The central angle and the arc degree always equal each other. So if this central angle is here, okay, VT, the arc, VT, arc, is also 55 degrees. Okay, so those are some things you're going to get a chance to look at circles with lots of chords and radius and diameters mixed in, and you're going to have to give different degree measures. So whatever the central angle is, the arc matches it. Okay, vertical angles still apply. Okay, I also know that half a circle, I'm going to change colors again here. Okay, if I have half a circle, okay, I know that this is 55 degrees. Could you tell me what that angle is? Well, we know that the diameter is half the circle. How many degrees is that? Well, that's 180 degrees. So you would take 180 and you'd subtract 55. So this would have to be 125 degrees. That's what would make up the other central angle. Therefore, the arc from Z down to T, this portion of it would also be 125 degrees because the central angle always matches the arc. And the arcs half of the arcs have to add up to 180. A full circle has to add up to 360 degrees. Okay, a few other things about chords. We would know that if the arcs out here are equal, are congruent, okay, so those two arcs are congruent to each other, that means their chords are the same distance. So this length here would be equal to that length there. Now I don't know what that length is, I don't have enough information in my picture, but I do know that those chord lengths will have to be congruent if their arc lengths are congruent, if their arcs that match are congruent to each other. It says a radius perpendicular to a chord bisects the chord. So here's a radius of the circle. If you see a perpendicular sign there, then you know that this chord has been bisected. You can see the congruent marks here. It's been cut in half. So on this picture down below here, if the distance from G over to C is 2, that means the distance from G out to A has to be 2 as well, because this is a radius in the picture and it's perpendicular, so that chord has been bisected. They ask you a few questions here, and you're going to see a few of those on your quiz, but more of the questions on your quiz are going to center around naming the different arc degrees, and that's going to be about the central angles and things like that. So give that a shot, see how you do. Tune into the Zooms and ask questions if you're struggling with that.